Every day, Londoners travel 2 or 3 miles to work by tube. Every day, miners travel at least this distance after they've gone down the mine. Miners will do most of their journey by man-riding train, the rest on foot. The rock pressures at work dip the roof and lift the floor. The effects of this rock squeeze are always evident in a mine. The tube traveller goes down about 80 feet, the miner thousands of feet. 3 post office towers, 1,900 feet, represent the average depth of a mine shaft. From shaft bottom, the miner travels several miles along a main roadway to the coalface, finally reaching it by a gate road leading from the main roadway. The gate road used by men and materials is called the tailgate. There are 2 gate roads to every face, and the other, the main gate, is used for conveying coal. Most coal faces are long wall coal faces. A long wall face is simply a long wall of coal, usually about 200 yards long. It may be less than 4 feet thick, it may be more than 8. The thickness is the height in which the miner works. Getting the coal off the face is roughly like slicing a bacon joint. As each slice is extracted, the surrounding layers behave like a sandwich cake from which the cream is being scooped out. Unless these layers are supported, they will collapse. The rock in roof and floor squeeze together to fill the gap. Immediately behind the coal face, powered supports keep the roof up, advancing with the machine as it slices off the coal, and letting the roof collapse behind the working area. Powered supports are hydraulic, working on the same principle as the car jack that lifts a wheel off the ground. The gate roads running down to each end of the coal face are supported with permanent steel arches. On the side where the coal has been extracted, these arches are reinforced with tack walls, built with rock, either packed in bags or blown in by machine. Arches and packs have to keep up with the face. Continuous mechanized mining is now a commonplace. Coal is won on every shift, 3 shifts a day. But just after the war, it was a different story. It took 3 shifts to cut and load the coal. This was the cycle of operations. On the night shift, the coal was undercut. Shot holes were drilled in the coal face. Then they were charged with explosives. The coal was blasted and brought down in a heap all the way along the face. On the day shift, the coal had to be broken up and shoveled onto the face conveyor. At least 40 men were needed for this on a 200-yard face. On the afternoon shift, everything was moved forward. Cocks were reset and the face belt dismantled to be re-erected in a new track. The 3-shift cycle was then ready to start all over again. Now the machines have taken over. The operation that took 3 shifts is done in 1, and more effectively and economically. The traditional image of the miner with his pick and shovel is a thing of the past. The revolution in mining only came about after nationalization. Money and resources were made available to reorganize the industry on a massive scale. The big changes was the introduction of the cutter loader, which could both cut the coal and load it onto the moving face conveyor at the same time. Another change, equally important, was the armoured flexible conveyor. The cutter loader can run on the strong sides of the conveyor, and the conveyor can be pushed over mechanically. Powered supports also made a great contribution. Working together with machine and conveyor, they push over the conveyor and then advance themselves to support the newly exposed roof. So production on all shifts has been achieved. Although the average is over 600 tons of coal per day, some faces exceed 2,000 tons. Once, a mine had as many as 10 or 15 faces. Now it's usually 3 or 4. But these few produce more coal with less manpower. They're mostly long wall faces, advancing slice by slice up to 3 shifts a day. The coal advances the face away from the main road, so the gate roads have to be constantly extended to keep open the lines of supply and travel. There's another system called retreat mining, where the gate roads are driven out to the end of the section to be worked, and the face retreats back between them. But whatever the system, a cutter loader is used. The coal may be sliced off by a shearer, scraped off by a plough, cored out by a trepanner. The choice of machine is determined by the different physical conditions on each coal face and the kind of coal needed. A nucleonic sensing device has been developed which guides the cutter loader in the coal seam and prevents it from breaking into the surrounding rock. Advancing coal faces extend the boundaries of the mine. The roadways must follow them because they serve men and materials and coal, and they circulate air. There must be a steady flow of fresh air underground. Fresh air flows down the downcast shaft through the whole of the mine and is finally sucked up the upcast shaft by a fan. If the air were left to itself, it would find the shortest route between the two shafts, leaving much of the mine without ventilation. So the flow of air must be guided through the whole of the mine. It is drawn down the downcast shaft and along the intakes to the faces. From them, it is drawn along the return roads to the upcast shaft. The upcast shaft is boxed in at the surface to prevent the air from short-circuiting. Doors are placed across some underground roadways to guide the airflow. Where the return airway crosses an intake, an overcast or air bridge is built to keep the two streams separate. The deeper the mine, the hotter the air will be, because as you go down, the rock temperature rises. It gets warmer on its journey through the mine. Men and machinery give off heat. Without an adequate supply of fresh air, work would be impossible. One shaft takes men and supplies down into the mine. The other brings the coal out. The cages and skips are wound up and down on steel ropes, passing over friction drums. Roadways serve many purposes. They ventilate the mine, they carry power and water to all parts of the mine, and they act as arteries for men and supplies and coal. Without supplies, a mine cannot survive. Equipment and other materials, including the arches for the roadways, have to be constantly fed into the mine. Coal comes directly from the face onto another conveyor along the main gate. And from there, by a system of conveyors to one in the main road, like streams feeding a river. At the end of its run, the coal may be discharged into mine cars or into bunkers. great metal skips can carry up to 20 tons of loose coal at a time. When the coal reaches the surface, it is conveyed to the preparation plant. The flow of coal to the surface must keep up with production. Any stoppages in the conveyor system can halt the face work.
Hello, the garbage.
So information about coal faces and conveyors is fed directly to a control room on the surface, where difficulties can be sorted out without delay.
It's Bill Anderson there.
He's on his way out to 560. Off the circuit at the back end.
Where are they?
Gone is the long, tiring walking by, so wasteful of time and effort. Men can now travel by man-riding trains or by man-riding conveyors, leaving only the last bit to walk to the face. So roadways must keep up with the advance of coal faces. Some gauge roads are still advanced by conventional hand methods. But just as the traditional means of winning the coal gave way to machines, so too has this job. Machines like the road header are doing the job mechanically. They speed the rate of advance and make the work safer. Coal mining has come a long way since the war. But although conventional methods have been supplanted by machines, the old image of the miner as the man with the pick and shovel still lingers. That image has no reality today. The miner is a skilled worker in a complex and demanding industry. And as new techniques continue to improve methods, so new skills have to be developed. The cost of this revolution in mining has been high, but it's been paid for by increased productivity. Productivity that is vital in a world of increasing energy demands. The coal is there to be won.